This video goes over some applications of trig functions. So when you're given sinusoidal word problems, which means it could be a sine function or a cos function, you're always going to graph what you know first. Then you can use these formulas to find the rest of the values that you need for the equation. So for the amplitude, you can take your maximum value minus your minimum value and then divide by 2. For your equation of the axis, you're really finding the midpoint. So if you remember, your midpoint formula is plus. You've got your maximum plus your minimum divided by 2. And then k from before is 360 divided by your period. Okay. If you forever forget these ones, you can always use your base sine graph and cos graph to figure out which is which. So let's do an example of putting those into play. Okay, so here we're going to do a Ferris wheel. A group of students is tracking a friend who rides a Ferris wheel. They know that John reaches a maximum height of 11 meters at 10 seconds. So we are going to put that on our graph. Here I've labeled my x-axis going up by 5s. This is my time in seconds. And this is my distance above the ground, or the height above the ground. Yeah, let's say that instead. That might be better. So this is our height above the ground. And this is in meters. Okay, so let's plot those 2 points that we know. We know John reaches a maximum height of 11 meters at 10 seconds, so right here. And then he reaches a minimum height of 1 meter at 55 seconds, so right here. Now, if it takes him 45 seconds to get down to that minimum, it must take him another 45 seconds to get back up to the maximum. So we can have him here also at 100. So now I'm just going to sort of sketch my graph here. It looks kind of like a cosine function, so that's what I'm thinking of, but I need to know my parameters. So let's start off first by finding my axis, or C. So I'm going to do my max value plus my min value divided by 2, which in this case, my max is 11, my minimum is 1, which makes my axis at 6. So I'm actually, so right about here. So I've got y equals 6 here. The next thing that I'm going to find is my amplitude. So my amplitude, which is A, I've got my maximum minus my minimum, and I'm going to divide by 2. So 11 minus 1 divided by 2. So my A value is going to be 5. Now the last thing that I need to figure out is the period. So I know that it's going to take 90 seconds for one cycle based on what I've graphed. And my K value is 360 degrees divided by 90, which means that my K value is going to be 4. So let's put in what I know into the equation. I've got y is equal to, where's my A value? 5 cosine 4. Now, because I'm not starting right on the y-axis, I am going to have a phase shift. I've shifted my new graph 10 seconds to the right. So that means that I'm going to have t minus 10. And then my C value is going to be plus 6. Oops. Let's get rid of that ruler there. Plus 6. Okay. Now, I've used some kind of strange variables here. I'm going to actually change my y to make it an h. And then for good form, I'm just going to define the variables that I'm using. So let's let h represent the height above the ground in meters. And let's let t represent the time elapsed. in seconds. So this would be my t-axis, and then this up here would be my h-axis. Okay, so that's great. Now I've got an equation that's going to model my solution. I'm going to write it down here. And let's go back to what the question is actually asking me. I am trying to determine his height at 78 seconds. So that means that I'm looking for height when t is equal to 78. Because I have an equation, I can just substitute my value in here for t. Evaluating that using my calculator, I'm going to end up with 5 cosine 272 plus 6, which is going to give me, let's see what that gives me here. So 5 cosine 272 plus 6 is going to give me, I don't think that's the right answer. Let's check on my calculator. So I'm working in degrees, and I've got 5 cosine 272, and then plus 6 is going to give me about 6.17 meters above the ground. Okay. And if I look on my graph, 78 seconds is probably right around here. It looks like I'm just above my axis, which is 6, so my value makes sense. This example is a classic tidal wave problem. So the water depth in a harbor is 1.8 meters at low tide. This is going to be our minimum, and 5.4 meters at high tide. This is going to be our maximum, and we know that we've got a 12-hour cycle. So that means that our period is 12 hours. So the first thing we're going to do is sketch our application here. So let's draw on our D and T. Let's go all the way over here. So this axis is going to be our time in hours, and this axis is going to be our distance in meters. Okay, so let's call this our time of day. This is our depth of the water, and it's in meters. So we'll add on some values. So let's just go by ones here. So 2, 4, 6, 8, 10, 12. I may as well keep going. 14, 16, 18, 20. And then if I'm going up here, I'm just going to go up by ones. 1, 2, 3, 4, 5, 6, 7. So the first thing that I need to do is to figure out my axis of the curve as well as my amplitude. So let's find out my C value first, and I'm just going to do it up here. So my C value is going to be my maximum plus my minimum divided by 2. So this is going to give me 3.6. My amplitude is my max minus my minimum divided by 2, which is going to give me 1.8. So let's put those values on here. I'm going to use my ruler. So I've got about 3.6 there. That's my axis of the curve. And then I'm going up to 5.4 is my maximum. And then I'm going to go down to 1.8, which is my minimum here. So now I'm going to plot on what I know. I know that at 6 a.m. I am at my minimum. What that means is that it is going to take 12 hours for me to get back to that minimum point. That means that halfway between those ones, I must be at my maximum here. So at 5.4 at 12 hours. So sketching those ones together here makes me look like I have a cosine curve. If I go back 6 hours, I can also see that I'm going to end up back up at my maximum here. Okay. So the next thing that I'm going to do is state an equation. So I already have my A value and my C value. I also need my K value, and then I need to figure out my phase shift. Okay, so my k value is connected to my period, so 360 divided by 12, which is going to give me a k value of 30. So what that means is I can create my equation for cosine, which is actually easier because that starts right at a maximum, which is what cosine is supposed to do. So I'm going to have my a value times the cosine of 30 times t. Let's use a better variable here on the left-hand side too. We'll make this d. And then I've got plus 3.6. Okay. So the next one that I'm going to have is I'm going to do my sine function here. So for sine, I am going to have a phase shift, because what I know is that if I put this as my starting point, okay, where do I want to put my starting point here? If I put this as my starting point, which should really probably be closer to, this would be more accurate, going through like this, because I'm dividing everything. So I'd be going through about here at 3, and then I'd be going up through here at about 9. That would be a little bit more accurate. Okay, so right here. So if I picture this one as my starting point for sine, I've shifted my function to the right by 3, and I've also reflected it because I'm coming down to a minimum. So in order to do my sine function, I'm going to have a reflection, and then I have a phase shift to the right of 3 hours. So to do that, I'm going to put t minus 3, and I've got plus 3.6. Those are two equations that I have. These are not the only ones. Okay, I could have many more equations here. So the next thing that I'm asked to do is to calculate the depth of the water at 5:48 a.m. and 3:24 p.m. So at 5:48 a.m., let's call this my T1. I need to change that into a decimal. So I know I've got 5 hours, and then I need to figure out what fraction of an hour 48 minutes is. So 48 divided by 60 gives me 0.8. So I know that T1 is 5.8 hours after midnight. And then my second one here is at 3:24 p.m. So using 24-hour time, that is 15 hours. And then I need to change 24 into a fraction of an hour. So 0.4, so those are the 2 times. And then I'm going to substitute into my equation. I'm going to use my cosine one just because it's a little bit easier. So my D1 is 1.8 cosine 30 times 5.8 plus 3.6. And my D2 is 1.8 cos 30 times 15.4 plus 3.6. So this means that my D1 is 1.8 cos 30 times 5.8 plus 3.6. So that gives me an initial depth of about 1.81 meters. You can substitute it into your other equation if you want to convince yourself that they are the same thing. Our second equation here is 1.8 cosine 30 times 15.4 plus 3.6, which gives us a depth of about 3.23 meters. Okay. Here we go. Our last part is we're asked to find a time when the depth of the water is 4 meters. So that means that I'm going to set D equal to 4, and I'm going to solve for T. So let's do some work here. I've got 4 minus 3.6 divided by 128 is 0.222 repeating. which is cosine of 30t. I'm going to take the cosine inverse of both sides and divide by 30 to figure out what t is equal to. So cos inverse of that 0.22222 divided by 30 gives me about 2.57. Okay. So what this is going to tell me is that I've got 2 hours, so about 2 a.m. And then I need to change that 57. So I know that 0.57 equals some fraction of minutes out of 60. So x is equal to 60 times 0.57, which is about, we'll say about 34 minutes. So that means that at about 2:34 a.m., the depth of the water is 4 meters.